Welcome student. Today is our lecture contraction mapping theorem in metric space. Before starting this theorem, I told you some basic definitions whose useful for proving theorem. I know that you also studied in previous classes functions and metric spaces. Now we define first fixed point theorem. Fixed, let X be a non-empty set and let T such that X to X is set to a fixed point at the point X belong X if Tx is equal to X. Again repeat, let X be a non-empty set and let T such that X tends to X be a mapping is said to be a fixed point at the point X belong X if Tx is equal to X. Here X is a fixed point of T. For example, first, a translation has a fixed point, translation has a single fixed point. Second, a rotation of plane has a single fixed point. If T such that R to R and function of X is equal to X square has a two fixed point. देखिए, given f x is equal to X square and we know that f x is equal to X, so implies that X is equal to X square, implies that X minus X square is equal to 0, implies that X minus 1 is equal to 0, implies that X is equal to 0 and 1 has two fixed point. Now we have defined contraction mapping. Let X space, let XD be a metric space and let T such that X tends to X be a contraction mapping such that distance of Tx Ty is less than or is equal to alpha distance of xy for all xy belong X and 0 is less than alpha equal to less than or equal to 1. Now we prove the theorem. T X tends to X be a self map on metric space xd such that distance of tx ty is less than or equal to alpha distance of xy for all xy belong x and alpha belong 0 1 then t has a unique fixed point in x. Proof that given that xd be a metric space and let t such that x to x be a contraction mapping such that distance of tx ty is less than or equal to alpha distance of xy for all xy belong x and alpha 0 is less than 1 then we have to prove that t has a unique fixed point in x. x0 belong x be an arbitrary point in x and we define iterative sequence xn such that xn plus 1 is equal to txn is equal to t power n plus 1 x0. If we put x is equal to xn and y is equal to xn minus 1 in above condition, then we have distance of xn plus 1 xn is less than or equal to distance of txn minus 1 is less than or equal to alpha distance of xn minus 1 is less than or equal to alpha square distance of xn minus 1 xn minus 2 is less than or equal to alpha n distance of x0 x1. Implies that distance of xn plus 1 xn is less than or equal to alpha n distance of x0 x1. So for n greater than m, d xn xm is less than or equal to distance of xn minus 1 plus distance of xn minus 1 xn minus 2 plus dot dot plus distance of xm plus 1 xm is less than is equal to alpha n d x0 x1 plus alpha n minus 1 d x0 x1 plus dot dot plus alpha n minus m minus 1 d x0 x1 is implies is less than or is equal to alpha n d x0 x1 comma 1 plus alpha n plus alpha 2 plus dot dot plus alpha m minus 1 is less than or is equal to alpha n upon 1 minus alpha distance of x0 x1. Since 0 is less than alpha is less than 1, then dx0 x1 tends to 0. Thus sequence xn is a Cauchy sequence in x. Since xd is a complete metric space and we also know that every Cauchy sequence in x has convergent in x, so there exist such that xn tends to x as n tends to infinity. That is, limit n tends to infinity xn is equal to x. Also we know that T, and given that T is a contraction mapping, so every contraction mapping is continuous, so T is a continuous. Therefore xn tends to x implies that T xn tends to tx is equal to limit n tends to infinity T xn is equal to tx. Therefore tx is equal to limit n tends to infinity xn plus 1 is equal to x, implies that x is a fixed point of t in x. If now to show that x is a unique fixed point of t, if there exists another fixed point, another fixed point y belonging x, such that x is not equal to y. Distance of tx ty is less than or is equal to alpha distance of x y, implies that distance of x y is less than or is equal to alpha distance of x y. Since alpha is less than 1, then we get d xy is equal to 0 implies that x is equal to y, implies that x is a unique fixed point of t in x. Hence, every contraction mapping on metric space XD has itself unique fixed point in X.